Welcome to watch our tape record of V373 final project.
In this project, we use embedded system to implement another robot.
And we will display its track on the screen.
Hey, this is the setup of our project. This is the other robot, and on it, this is the microcontroller, and this is the motor driver here. And this computer can communicate wirelessly to this MCU, and the track of this robot can be displayed on the screen. Okay, in this part, I will introduce the display system of our project. And our project consists of the display system consists of these following parts. And the first part is the X32 MCU, which is the microcontroller we're using. And after this microcontroller will generate some digital signal, and the digital signal will be converted by a circuit, which we call it DAC, which means digital to analog. And after this circuit, we have a RCA signal, which is analog signal. And this analog signal will be either displayed by a TV set directly, or it will be converted to by a VGA converter and be displayed by another screen here. And that's it. And here's some detailed stuff. Well, the MCU, which is the microcontroller, will use some function like some modules like auto compare. The auto compare will generate some carrier wave, which will carry the video information, and it will be displayed on the screen. And the DMA module. As for DMA module, we will have some chunk of memory in the RAM of the MCU, and this memory stored the video information, and this part will be constantly transferred to the screen. And another module is used is called SPI, which is not actually this SPI is not used for communication, and this SPI was used to generate some waveform. The video information will be generated, will be transformed by these parts. And the DAC circuit, well, as I have said before, it is used to convert the digital signal to an analog signal here. And the VGA converter, well, whether it is used, that really depends. It is optional, and if we use this kind of screen, which do not have RCA signal inputs, then we will use this part, and we will use the VGA in that scenario. In this part, I will talk the more detailed version of the video signal. And you can see here, this is one bitmap, and it is stored in the RAM of the microcontroller, and we will constantly, we will periodically transfer this part, this chunk of memory, to the screen. And the signal will be generated like this. You can see there are several pulses here. These three pulses here are called synthesis signal. This part will determine the position of the image on the screen. And this part I said carrier here, it is kind of carrier wave, and it will carry the video information, which is transferred by the SPI module. And each carrier wave is generated by the auto compare, and the other part is generated by the SPI. Each one represents a video line here, and each frame consists of several video lines, and you can see that after transferring one frame, this bitmap will be transferred to the screen, and you can see the image on the screen. That is exactly like this bitmap.
Alright, now I'm going to talk about the assembly part of this auto robot. First, very basic things. We've got 6 batteries, 1.5 volts each, and in total 9 volts. And then we have 2 wheels used to move the auto robot. And then we've got 2 motors used to drive the wheels. And then here we have two boards. One is called PIC32 board, the other is the driver board. And then in the driver board we have first two pins, V-in pin and the ground pin. These two pins directly connected to this 6 batteries power source. And then we also have here 2 A-in port and 2 B-in port. These 4 ports will directly receive the input signals from PIC's I/O port. And then after receiving the I/O port, after receiving the data from PIC32, the motors will be controlled by those controlling signals. And then when we have the two motors drive the wheels to rotate in the same direction, we can have this auto robot move forward and backward. And then when we have the motors rotate the two wheels in not the same direction, then the auto robot will either turn right or turn left. And since we are intent to have this auto robot be controlled by a computer wirelessly, so we have a outside module of Bluetooth, and then it is interact with the UART module of the PIC32.
Our computer communicates with the PIC32 board using the UART protocol, so that we can control the auto robot using our computer directly. To make the controlling process easier, we connect our Bluetooth module on the PIC32 board, and then we can pair these two devices. And there is a built-in command line tool called the Screen in the macOS, and so that we can monitor the serial port on the computer. And then we can send some characters to the PIC32 board to control the auto robot. We predefine some characters here. For example, the capital F means when we send the capital F to the PIC32 board, and the auto robot will go forward.
Okay, now we have uploaded the program to the PIC32 board, and on the computer side, the first thing is to pair those two devices. The Bluetooth devices is called YF robot, and we need to enter the default code 1234 and then pair. Okay, it has been paired successfully. And then we open terminal and type screen /dev/tty YF robot, and the baud rate is 9600. And okay, they have been paired. This direction is the forward direction.
Yeah.
And that's F. B for the backward, turn right, forward, turn right, turn left, forward, backward,